Today we're going to be looking at the Globe Observer app, and you can get the app on the App Store, on Google Play, and this is what the icon for it looks like. We're going to be looking in particular at globe clouds, even though it can also look at other characteristics like mosquito habitat, land cover, and trees. We're going to focus primarily on looking at identification of the various types of clouds and cloud cover in your area to help complement some of the research being conducted by NASA.
GLOBE is a community of scientists, teachers, students, and citizens from more than 100 countries around the world. Their efforts in collecting information, or data, are helping us to better understand our environment. And now we need your help in collecting data so we can better understand the different types of clouds and the effects they have on Earth's climate. At any time, over 70% of the Earth is covered by clouds. And these clouds play a really important role in helping to control Earth's temperatures. For example, have you ever been outside on a hot and sunny day when a cloud rolls overhead and provides you with some much needed shade? Did you notice that the temperature suddenly felt cooler? That's because these clouds are blocking some of the sun's heat from reaching the Earth's surface by reflecting that heat back into space. Clouds like these that help to cool the Earth's temperature are lower to the ground and thicker, like big puffy cumulus clouds or the thick flat stratus clouds. On the other hand, there are clouds that actually help warm the Earth. These clouds are high in the atmosphere and made up of tiny ice crystals and are usually really thin. Cirrus clouds are a type of high cloud, and they let most of the sun's energy pass right through them, reaching the Earth's surface. These clouds also help to absorb some of the Earth's energy, preventing it from escaping into space, and so they act like insulation. Even small changes in clouds, such as overall cloud cover, cloud type, or the location where clouds form, can impact Earth's climate. For scientists to understand these effects, we need accurate data on clouds. And NASA has a number of satellites orbiting Earth and collecting data on clouds and Earth's energy. And while these satellites give us a big picture of what's going on, we sometimes have some trouble with the details. Plus, we need data from your vantage point, right here on Earth. Satellites only see the tops of clouds, while you see the bottom. And so by putting these two vantage points together, we get a much more complete picture of clouds in the atmosphere. I'm really excited for you to start collecting data through the GLOBE program. You know, before I started working at NASA, I was a GLOBE student.
When you're using the Globe Observer app, there is a cloud wizard that will ask you a series of questions that will help guide you in identification of the clouds that you're currently observing in your area. However, it might be helpful as well to be familiar with this cloud identification chart prior to going out, and maybe even taking it along with you as you're outside doing your identification. So the first page of this identification chart deals with the altitude of your clouds, so how far they are from the Earth's surface. It deals with the high level clouds, and it gives you pictures to help you identify them correctly. And then it gives you the mid-level clouds, which are typically between 2 kilometers to 6 kilometers above Earth's surface. And as well, it gives you the low-level clouds. And as well, what clouds are usually associated with rain and thunder. So this is very helpful information. The second part of this involves observation basics. So at times, it will ask you to identify sky color, sky visibility, and there's pictures there to help you, guide you along in making the correct observation. And as well, cloud cover and cloud opacity is two of the other things that will be asked about. And there are visual representations here to help guide you along in making the correct observation. So this chart will be something to get used to looking at and use prior to going out, and maybe even having it while you're out in the field making your observations. All my information is entered, and within 30 seconds of doing that, I receive an email with my password for this app. If I didn't like my password, I can certainly go ahead and change it by going to www.globe.gov and change it there. All I'm going to do now is go ahead and enter my password so we can get started with this app. Finally log into the Globe Observer app, you are directed to these app intro pages. Basically letting you know that your observations are going to be stored on your phone or your tablet until you actually click send. And it's important that you do click send if you want to be able to share with students, teachers, NASA, and citizen scientists worldwide. The second page here indicates that permission to access your location will be requested after you log into this particular app, because these features, when they're enabled, will enhance the app's capability and contribute a lot of value to your observation to scientists, because they will then be able to compare your location and your observations at your location with those taken by the satellites. Here are some privacy and safety considerations. Please read through them, as well as communication. And I'm just going to click on agree, but certainly take the time to review those. So now we have the Globe Observer app open, and we're going to be looking at and observing the clouds in your areas. So there's 4 different areas here that you could potentially choose, but we're going to choose the Globe Clouds protocol. So I'm just going to click on that. There's some introductory information here which is very useful for you to read through. And the biggest things I want to point out to you is if you make your comparisons within 15 minutes of a satellite passing overhead, then you're able to compare your observations to those taken by the satellite. And in addition, you can also observe your cloud cover and your cloud conditions at solar noon, and this allows you to more easily compare your measurements with other Globe users. And there's notifications in this app that will tell you the time of day based on your location when satellites are passing overhead and when solar noon is for your area. So I'm just going to click on next, and basically it gives you a what to do list here, how to make a cloud observation. And the app, there's an in-app wizard, helps walk you through this entire process. So this is very helpful as well, which is just amazing. And what do you need? Basically, after you make all your data, then you will be given an option to send your data into the Globe system. So you can use the app at any time. And as well, they have a link there for extended training slides if you want to get a little bit more information on actually making your observations. Biggest thing to note here is the first time you make these observations, you might feel a little bit uneasy or not sure if you're actually making the correct identification. But the biggest thing is the more you use this app and making observations, the better you will get at making your cloud observations and determining what types of cloud cover and cloud types that you have in your area. Select next to go to the main screen. So this is the screen or the menu that we're going to be looking at when we want to make our cloud observations. The first thing that I like to do when I open up this app is to check my satellite flyovers from my area. So I'm just going to select the orange button there, and based on my latitude of 48.9601 and longitude of -57.9346, I can see when the different satellites are passing overhead. So we can take our measurements and our cloud observations anytime we want. However, if we take them within 15 minutes of the satellites passing overhead, then we can help verify the satellite measurements as well. As you see here, I see that Wednesday, there's the satellite Terra, Aqua, and Terra. And Thursday, I can scroll through and see the different times, and as well Friday. Now, I can set notifications for this as well. So if I just select that gray button, I can select when the solar noon is going to happen and when the satellite flyovers are going to happen for my area. And I will get notifications 15 minutes prior to these times. So this is really helpful if you want to actually take your own observations and help them verify the observations that are being observed from the satellite. Not 100% needed, because you can take your observation at any time, but super useful because then you're helping to contribute to the verification of the data that is happening and is being observed by the satellites. And I scroll down, This notification is being optimized for my location, which is perfect. I'm just going to click on return and go back to this screen. Now I want to go back to the main screen. So at the top here, I'm just going to hit the back button, and I'm now ready for my new cloud observations. So when I click on new cloud observations, it gives me my local time, my latitude, longitude, it gives me a map of where I am. Now I'm just going to click on next. So what does your sky look like? Right now, I could say that we definitely have clouds in the sky. So I'm going to click that. What percentage? It's overcast here now. Looking at what's around me, we have a little bit of drizzly rain, so definitely is 90%. And the clouds look very much like this, sort of dark and gray. So now I'm just going to click on next. And it says if you're comfortable identifying clouds by type, you can do the manual cloud identification or use the guided cloud identification wizard. I'm going to use this. You can either skip the wizard introduction or use this cloud wizard and its introduction to help you when you're making your observation. So right now I'm out in an open field and I'm going to be using this wizard, and I'll go through this wizard to help me. So just click on the green next button. We're going to be using this cloud triangle, and it's going to be a useful tool for helping us to determine if we have low, mid, or high level clouds. So I'm going to click on next. Now, when you're using your wizard, you might see some puffy clouds. So how do you determine if they're low, medium, or high? If you actually take your arm and just extend it slightly above your head, and if those clouds are the size of your fists, then they are low level puffy clouds. If the clouds are the size of your thumb, they are medium level puffy clouds. And if they're the size of your pinky, then they're high level medium puffy clouds. As well, we have visualization here for what layered clouds look like, what wispy clouds look like. So anytime we choose that, there's going to be a check mark associated with our response or our observation. After you identify the cloud types, you can, if you want, identify the percent cloud coverage and opacity for each of the different cloud levels. I'm not going to do that. We're just going to, but you certainly can and investigate it if you like. Now I'm just going to scroll through this so that we can start our actual observation. So let's click on next. When you have all your observations done, then you can send your data up to the Globe network and compare your findings with others and look at your findings and observations over time. So let's click on let's get started. The first thing that we're asked about here is high level clouds. Do you see any contrails? And if you want to learn more about contrails, you can select that at the top here, or if you're okay with that, just determine which one of these options you have. Looking up at my sky is a fairly overcast day with a little bit of drizzly rain, so there's no contrails visible. That's my option, so I'm going to choose that. Next question asks you, is there any thunder, lightning, and or heavy rain? So now we're looking at the low level clouds. And there's no thunder, lightning, and or heavy rain in my area, so I'm going to select no. Is it drizzly with small rain droplets? It is slightly drizzly here for me, so that's my conditions, and I'm going to say yes. The wizard will ask me, is my cloud nimbostratus? And I can learn more about this cloud, but I definitely know that yes, this is the cloud that I have right now. So as you can see, because I have rain, my low level cloud type would be nimbostratus. So I'm going to say yes, keep. Now I'm going to select done, and these are the clouds that I've identified. And if I'm happy with that, I'm just going to click next. Now it's going to ask me to quickly check cloud cover and visual opacity. Click next. It'll ask me to, if I want, I can observe the cloud cover for high, mid, and low. I do not need any of this if I don't want it. It's not necessary. The only thing that is absolutely necessary is the overall cloud coverage. I'm just going to leave that alone and click on continue because I already have my required data, but if you want, you can observe and put in the cloud cover for the high and the mid-level clouds as well, but I'm not going to right now. So now it's going to ask me for the surface conditions and select yes or no for each of the following surface conditions. So right now in the field that I am standing in, there's some standing water, it's a bit muddy, and there's some snow on the ground. So I have yes to ice and snow, yes to standing water, and yes to muddy. All the other things would be no. actually, raining or snowing, that would have to be yes, because it just went from drizzly rain to snow. So click on next. Now it asks me to take pictures of the sky so that I can also have them as part of my data collection. So I'm going to choose the green take pictures, and it's going to ask me to rotate so that I have my phone in a landscape position, and I have to line up north, south, east, and west. Once that happens, it takes a picture. And north is done. Now I'm going to do west. Line it up. I'm going to rotate around in this field. Go to south, line it up. I'm not very good at this. And then go over to east and take a picture as well, so I can get a 360-degree view. Now it'll actually ask for up and down as well, so I can certainly do that. Down is taken, and then scroll upward. I have all of my pictures taken, and I would just click on done. Let those pictures render and actually come up on your screen, and then you can click on finish. Now your data has been stored successfully on your device and is ready to send to Globe. So you don't have to send your data now. You can send your data when you actually get to an area where you have Wi-Fi or you have cell phone service. But when you're ready, you would just click on send all cloud data now. And one observation has been collected. And it says sending submissions. It's sending all the photos, and you can see your status, and that's all you need to do in order to contribute your observations and your citizen science research as a part of this Globe app. When your observations have been sent successfully, you'll receive a little message which will pop up on screen saying that it was done successfully. This is the final screen that you will see. You have some different options here, so you can click on see my data or see today's cloud measurements that were taken by other Globe observers. And the bottom, you can also see current NASA data, and you can click on that if you want to as well, and you can explore a little bit. The other three things that you see here about mosquitoes, land cover, and tree height, those are the other three observations which are being collected by Globe app users around the world.